Hello guys, welcome to my lecture series of digital electronics. In today's lecture, we are going to discuss about double double method. It is the most important and most popular method to convert any number from decimal number system to any other. But before we get start with today's lecture, let us look at the solution of the practice example that was given to you in my previous video. So the problem was to convert 882 from hexadecimal number system to decimal number system. Okay, so for that we do have many methods, but as per the previous lecture we need to adopt streamline method for the solution. So according to streamline method, what we will do, we will put the squares with the increasing power of radix. So here radix power 0, then radix power 1, radix power 2. Okay, here the given number is in hexadecimal number system, so 16 raised to 0, 16 raised to 1 and 16 raised to 2. 16 raised to 0 is 1, 16 raised to 1 is 16, and 16 square, as we all know, is 256. Now what we will do, we will put the coefficient as per its places over here. So here I will put 2, here I will put a, or a is nothing but 10. Okay, the meaning of a for the calculation purposes is 10, and in this place I will put 8. So equivalent decimal number of 882 is 8 into 256 plus 10 into 16 plus 2 into 1. Okay, so this multiplication will turn out to be 8, 4, so 2048 plus 160 plus 2, and addition of this will be 2210. So equivalent number or equivalent decimal number for 882 is nothing but 2210. Okay, so this is the solution of the practice example of previous lecture. Now we will move towards double double method. So this method is used to represent any decimal number into any other number system. It performs successive division of given decimal number by the radix of other number system and will record the remainder in each step till the divisor becomes 0. To calculate fractional parts, successive multiplication is performed till the operand becomes 0. Okay, so when we will have some examples, at that time these two statements will be very clear in your mind. For now, let us have some idea regarding Euclidean division. So Euclidean division method, that is very popularly adopted. So a number which should be divided, that number is called dividend, or symbolizes as B. The number by which division is carried out is called the divisor, and it is represented by A. The maximum multiplier by which we can operate the multiplication is called the quotient, and after having a subtraction, then we will have remainder. So remainder may be 0 or it may be non-zero. Okay, so let us have an example. If we want to divide 38 with 5, then 38 is our dividend over here, 5 is divider over here. The maximum multiplier of 5 is 7, which is nearer to 38. Okay, so 7 will be the quotient, and if we subtract 35 out of 38, then we will have 3 as our remainder. And this concept was introduced by Euclid, so we refer as Euclidean division. So B is equals to P multiplied by A plus R, where P is quotient and R is remainder. Fine. Now let us have an example. So here the problem is to convert 59, which is a decimal number, into binary, octal and hexadecimal number. Okay, so what we will do, so we will have a successive division. So we will write 59, which is our dividend, and if we want to convert it into binary number system, then what is the radix of binary? Radix of binary is 2. So we will have the successive division with divisor as 2. So we will divide this 59 by 2, and doing so we will have quotient as 29 and remainder as 1. We will list out the remainder at each successive division. Okay, now we will again divide 29 with 2. Doing so, we will have quotient as 14, 14 2s are 28, and remainder as 1. So we will take record of that remainder 1. Then, as we know that double dabble method is successive division, so we will continue this division. So we will divide 14 by 2. We will have quotient as 7 and remainder will be 0, because 14 is exactly divisible by 2. Then we will divide 7 by 2. We will have quotient 3, remainder 1. Again, if we divide 3 by 2, then we will have quotient 1 and remainder also 1. Then finally we will divide this 1 by 2. So now the maximum multiplier of 2, that is less than 1, is 0. Okay, so 2 multiplied by 0 is 0 and 1 minus 0 is 1. So these are the quotient. So this third column are remainders at each successive division, and up to what step we will continue this division, so till our divisor will become 0. Okay, now as it becomes 0, if you perform more successive divisions, then you will always have 0 remainder for all the further division. Okay, so we will stop over here. So we will continue this successive division till our divisor become 0. Now whatever the remainders that we have listed should be arranged from bottom to up. So most significant bit is the latest remainder and least significant bit is the very first remainder. Fine. So in other way, 59 into decimal can be represented by 1 1 1 0 1 1 into binary number system. Fine. So its operation is very easy and very convenient, but sometimes what happens, if the given number is higher, then the number of divisions will be higher and it will take some time. Otherwise this method will guarantee the short conversion of any number from one number system to another. Moving further, our next case is to convert the same number 59 into octal system. Okay, so what will be the change over here? So obviously the name is double dabble method, so we will perform successive division, but now I am interested to convert it in octal number system, and radix of octal number system is 8. So we will have the successive division, but this time our divisor will be 8. So write 59, divide it by 8, and you will have quotient as 7 and remainder as 3. Now you will again divide 7 with 8, then you have 0 quotient because 8 divisor is greater than dividend. So quotient will be 0 and the remainder will be 7. And again same way, the latest remainder will be the most significant bit and the very first remainder will be least significant bit. So 59 into decimal can be represented as 73 in octal number system. Similarly, for the same number 59, if we want to convert it in a hexadecimal number system, then now I think you got the idea very well. Radix is 16, so we will divide 59 by 16. You will have a quotient 3 and remainder as 11. But as you know that 11 is not a character of hexadecimal system. A character equivalent to 11 is B, capital B in hexadecimal. Now 3 divided by 16, so as you know that if divisor is greater than dividend, then quotient will always be 0, and once quotient becomes 0, then you stop the division. So my latest remainder is 3 and my first remainder is B. So 59 into decimal can be represented as 3B in hexadecimal. So in this way, double dabble method is very effective method by which you can convert any decimal number into either binary or octal or hexadecimal number system. Let us take one general example, 108.125, which is given into decimal number system, and we need to convert it into binary, octal and hexadecimal. So in the case where such kind of fractional number are given, we need to proceed differently for integer part and for fractional part. So for integer part, which is 108 over here, we will perform successive division. So we will make 3 column. Now we are interested to convert this number into binary. So we will divide it with the radix of binary, which is 2. So 108 divided by 2, you will have 54, remainder 0. You will again divide 54 by 2, you will have 27 and remainder will be 0. You again divide 27 by 2, you will have 13, remainder this time will be 1. Divide 13 by 2, you will have 6, remainder 1. Divide 6 by 2, you will have 3, remainder 0. 2, quotient 1, remainder 1. Again dividing 1 with 2, you will have 0 quotient and remainder 1. And you will write from bottom to top. Okay, so here 108 in decimal can be represented as 1 1 0 1 1 0 0 into binary. Now let us operate for fractional part, which is 0.125, and as we discussed in the very first slide of this lecture, that fractional part we need to operate the successive multiplication with radix obviously. So 0.125 multiplied by 2, so you will have 0.250. Now in this case you will list the integer part. What is the integer part over here? It is 0. Okay, so just note it aside. The fractional part will be the next operand for multiplication, so we will multiply 0.250 with the radix and you will have 0.50. Again the integer part will be noted separately, so 0 is the integer part and fraction part will be the operand for next multiplication. So this is 1.00. Now integer part is noted as 1 and fraction part is the operand for next multiplication. So now you will observe that for every next multiplication it will give you 0 only. Okay, so when operand becomes 0, we will stop our successive multiplication, and the integer part MSB was listed as last remainder and LSB was listed as first remainder, but in fractional part we are performing successive multiplication, so we will move from upside down. Okay, so we can write 0.125 into decimal can be represented as 0.001 in binary. Okay, so now the whole number 108.125 into decimal can be represented as 1101100, which is the representation of 108. Now this decimal point will become binary point over here, and 125 will be 001. Okay, so this is the equivalent binary number of our whole number 108.125. Now I want you to perform the same thing for octal and hexadecimal number system. Okay, so if you want to find the octal equivalent of 108, then what we will do, so we will have, okay, let's just have the quick calculation for this conversion also, then you please try hexadecimal by yourself. Okay, and consider me available for any doubt. If you are not getting any answer, you are free to ask me either on the comment section, or you can also send me an email. My email ID is also given to you in description box as well as my thumbnail. Okay, so let us just erase all these things. And see, double dabble, many a times many students know how to convert one number from one number system to another, but they don't know the name of that method. Okay, so I request you to just remember the name. This method is called double dabble method. Fine. Now again, if you want to convert 108.125 into octal, then integer will be treated separately, fractional part will also be treated separately. So 108 integer part will have successive division with radix. So now octal number system has radix as 8, so 8 1, and here we will have 28, so we have 13. Okay, and we will have a remainder 4, because 13 multiplied by 8 is 104, and we will have remainder, yes, correct. Then again we will divide this 13 by 8 and we will have quotient as 1, and 13 minus 8 will give you 5, because 8 plus 5 is 13. And then we will again divide 1 by 8, so quotient will be 0. Now we will stop our division over here and the remainder will be 1. Okay, so and if we write it from downside up, then 108 into decimal is equivalent to 154 octal. Okay, now what will you do with fractional part? So 0.125 will be treated separately, but for fractional part we will have successive multiplication. So we will multiply it with the radix, which is 8. So doing so, we will have 0, 0, 0, 1. So in the very first step we are getting 1. Again we will list out the integers separately, and fractional part will be our next operand. Here in the second step only our operand become 0. So we will stop our multiplication on this step. See, many a times what will happen, that you will never have this operand as 0. So at that time you may calculate 3 or 4 digit after the point. Okay, but here we are getting 0, so we do not have any concern about that. But multiplication will be listed from upside down. Okay, so 0.125 in decimal is equivalent to 0.10 in octal. Okay, so now the whole number 108.125 into decimal number system can be represented as 154.10 into octal. Now here this point is called decimal point, and this point here is called octal point. Okay, so now you can have the same kind of calculation for hexadecimal. What will you have? You will just have successive division with the 16 and successive multiplication with 16. Okay, so by doing so you will have 2 over here and 0 over here. So fractional part will be 20 or so 0.20. Okay, and integer part, it is also very easy to find out. So if we divide 108, okay, it will be better if you perform it by your own. Fine, so that you can easily determine that whether you understood the concept or not. Moreover, see, this is the example that we have solved in this video lecture. So we have converted this 59 into binary and we got 111011. Okay, then in octal we got 73 or 73, and in hexadecimal we got 3b. Fine. So as you can observe over here, in the number system where number of characters are more, the length of that number will be less. So here we are having 10 characters, so only 2 digits are sufficient to represent 59. Here in binary the number of characters are 2 only, so we require 6 digits. Fine, as you can see 111011, so we will require 6 digit, or the digit of binary is known as bit, so we require 6 bit. In octal number system we are having 8 characters only, so we require 2 digit, but as you can see the face value of that 2 digit will be increased than decimal. Okay, and here the face value will be decreased than decimal because we are having 16 characters in hexadecimal number system. Okay, so for the activity part, you just try to convert these 3 numbers 196, 243 and 1008 into binary, octal and hexadecimal system. Fine, so total 9 conversion will be required, but that will definitely improve your computational skills. Thank you.